Добрый день.
So good morning, ladies and gentlemen. Good afternoon. Let's get started. So we'll be starting in about several minutes. We have quite a few interesting presentations for this afternoon, and we also expect your feedback, and we look forward to getting your feedback on our schedule. So it's really important to get your feedback on the presentations so we can choose the presentations that would be of most interest to you. So it's about time we get started, I should say, and so you can see the first presentation in on the screen, and we can start, I think. Kevin, it's over to you.
Okay, thank you. Can you hear me okay? Let me just share my screen. Okay, can you see my screen okay and hear me okay?
Yes.
Okay. Okay, thanks very much. So yes, I'm Kevin Maynell. I'm working for the Internet Society, but I'm also working on a project called Manners, or also known as Mutually Agreed Norms for Routing Security. So I did present Manners about probably 2 or 3 years ago at ENOG, but there's been quite a few developments since then. And in particular, I'd like to introduce the observatory tool that we've developed over the past year or two. So that's really about what this presentation is going to cover. Just very, very quick background. Obviously, ENOG is a technical group, so I think you should all be aware of how the global routing system works. But there are around 70,000 autonomous systems connected to the internet, which each use a unique autonomous system number to identify themselves. Of these, around 10,000 are about multi-homed. So in other words, they connect to 2 or more other networks. And it's these 10,000 that we're probably mostly interested in. As I'm sure you're also aware, routers use BGP to exchange reachability information. In other words, the networks that they know how to reach. From this, they build routing tables, and then this is used to pick the best route to send packets across the internet using various different metrics. So that's the real basics of routing, in case you didn't know. But the problem is that BGP is based entirely on unverified trust between networks. There's no built-in validation that BGP updates are legitimate. Basically, any network can announce anything, can announce any resources, so it could announce any prefix or any AS number. And there is, a lack of validated and reliable resource data on the internet. So it's very difficult to check whether a network is authorized to originate the resources that it advertises on the internet. So the upshot is that the routing system is under attack for various reasons. There are sort of 3 main problems that you see in the routing system. One is route hijacking. So this is where a network operator or an attacker is impersonating another network operator. This causes packets to go to the wrong place. It can be used for denial of service attacks, also traffic interception. And there have been a number of infamous incidents, perhaps most recently in 2018. Something that's very similar is a route leak. So this is where a network operator accidentally announces they're able to reach another network. It's usually not intentional. Usually the traffic will find its way to the right place, but it can cause delays, it can cause traffic to be blackholed. And actually this is something that's maybe even more common than a route leak. There's been at least 2 major route leak incidents this year alone, which caused quite significant disruption on the internet. So it's obviously a problem that we need to address. And then finally, you have IP address spoofing. So this is essentially forging the source IP address on a packet. So in order to hide the identity of the sender or to impersonate another computing system. And this is the root cause of reflection DDoS attacks. So that's the real basics of what the routing incidents are. Obviously you hear some from time to time. Some of these get into the press. The Telstra one was quite well publicized. Curator Labs also identified a big route leak in Brazil, I think back in June or July. So yeah, kudos to them. But actually, you see this happening every day. This is not a unique occurrence. These incidents are happening all the time, and some have bigger impacts than others. But ideally, we would like to eliminate all of these. So this is where Manners comes in. So it's really nothing new. It's just really bringing together a number of long-established and well-defined industry practices. But what it's doing is bringing these different actions together into a sort of one package and say, well, if you implement these actions, you can eliminate most of the common threats in the global routing system. And it's about, by signing up to Manners or participating in Manners, what network operators are doing is making a statement to say, look, we're taking shared responsibility for the internet infrastructure. We're collaborating with responsible operators to make sure these incidents don't happen, or at least we can reduce the number of incidents. So there are 3 main programs. The first one that we launched was the network operators, but there are also programs for IXPs and CDN and cloud providers. And what I should say is that this is not something that you have to pay money towards. This is supported by the Internet Society, and it's entirely free to join. So for the network operators program, there are 4 actions. The first is to ensure that you do correct route filtering. The second is an optional one. So this is to prevent, it's anti-spoofing, so to prevent traffic with spoofed source IP addresses. The third action is to really just to ensure that you have up-to-date contact information in a publicly accessible database. Usually this is the RIR whois databases, but for some of the NIRs, particularly in Brazil, they don't have public information available for various reasons. So in that case, we encourage networks to put this information into PeeringDB. Actually, we encourage everyone to put this information into PeeringDB, but that certainly if they have no other option, that's one thing that they can do. And then finally, you have the action 4, which is global validation. So this is really about registering your routing data in an IRR, in a globally recognized IRR. But more specifically, what we would really like networks to do is to create ROAs for their number resources. So ultimately, that's where we would like to get to. There are very similar types of actions for the other programs. I'm not going to go into too much detail with this. The slides are available, but for the IXPs, there's some slightly different actions that they need to undertake because often they're not advertising AS numbers, for example. But we also have the CDN in Cloud program, which has very, very similar action to the network operators. So the observatory is also applicable to them as well. Okay, so that's all very nice. Okay, but how do you actually look at individual networks and say, okay, how are they performing? How are they conformant with these different actions? In other words, how can you actually check and provide evidence that they're doing, undertaking the actions that they've committed to doing? And this is really where the observatory comes in. So we developed this tool to basically independently, impartially benchmark ASs in order so they can sort of look and say, well, that we're doing the right things. The other reason is to have a look at, try to record the sort of factual state of routing security. So we can go back and look over time and see whether the problem is getting better or worse. So we have about nearly 2 years worth of data now, and we can sort of look at and say, well, okay, is the problem getting better or is it getting worse? And it also helps when you look at individual networks, you can see sort of their track record over time. You can say, okay, are they generally doing, if they've had an incident, is this just a one-off or are they persistent offenders? But this is really useful for helping networks check, check for their own conformancy. Definitely what we found is a lot of networks didn't realize they had problems. They've been able to use this tool and then they've been able to quickly identify where they have issues and some of the things that they need to fix. Now, the observatory itself, it doesn't, we actually don't create the data ourselves. So this is coming from publicly available data sources. So for example, the route incident information is coming from BGP Stream. We pull the CIDR report to look at bogons. We look at the CADA spoofer database. And then we pull the actually the various RIR databases, PeeringDB, a number of IRRs, and then we have been looking at RPKI validator. That's going to have to change in the next year because obviously that will probably be going away. But there are alternatives, so we'll replace that. Okay, so now I'm going to just basically give a demonstration of the observatory. So it's a website you can go to, observatory.manus.org. And yeah, I mean, it's very simple on a basic level. You have the 4 actions, the 4 network operator actions: filtering, anti-spoofing, coordination, IRR, global validation. And that's split into 2. So you have IRR and RPKI. So the last 2 circles are split between, well, they're action 4, but they're split between the 2 things. So you can very quickly see, how you're conformant for a given network or a group of networks. It doesn't have to be one network. So at the moment we're looking at the whole of the internet. So generally there's a relatively small number of routing incidents compared to all of the routes on the internet, but actually even 1% is quite a lot. So it does amount to quite a significant number. For anti-spoofing, this is the one action that we can't check passively. So networks actually have to run the spoofer software and upload their results to CADA. So most networks haven't done that, so we don't have that information, but we do record what we have. So for the coordination, most of the networks in the world look like they're pretty good at putting their contact information in. Some are not. The same for IRR. So yeah, 87% of the networks in the world recording their routes, or most of their routes. And then of course you have RPKI, which has limited deployment at the moment. So as you'd expect. Okay, so this is the world, or the internet. So you can actually look at these statistics by country. You can look at them by RIR region. You can look at them by UN region and sub-regions as well. So you can aggregate statistics for different regions. That's not hugely interesting. It's really for academic purposes. But what we can definitely do is you can create what we call favorite groups. And I need to log in again for this. You can create your own custom groups. So I've created one for ENOG, so you can see all of the networks in ENOG. You know, and again, actually, it looks like ENOG countries are very similar to the global average. Actually, probably slightly better. So it looks like every network in the region actually records its contact information. It's actually doing pretty well on IRR, and RPKI is about the same as the rest of the world. So we can look at that. Now, okay, so again, this is the aggregated information, but we can actually look at this information for every network in the region. And you can take, for example, the Russian academic network. You can look at their individual details for all of the different actions here. Okay, so again, that's sort of a useful thing to have. But I'm going to just focus on one particular network, which will remain nameless, but I'm sure you can look it up. You know, I'm not picking on any particular network here. It's just one I'm using for example. I would say that most of the networks in the ENOG region are actually, you don't really see many big problems. They're pretty much doing the right things, it looks like. So this is just really for example. Yeah, so you can actually look at where they've had problems here. So this is really the information for November, and you can see they've had one route leak here. It looks like it's been running all month, and you can see the prefix is 91.207.82. You can look at the path through in the internet, and there's the BGP stream reference there if you need more information. Okay, there's also a hijack. Again, you can see which prefix that's coming from, and the path, and there's a BGP reference, a BGP stream reference there. To be fair, sometimes you get false positives. This may not actually be a hijack, but yeah, it just gives you some indications. You can also look at bogons. So there's a number of bogon prefixes being propagated here. You're able to identify those, and on the ASNs, there's a number of bogon ASNs as well. These look like there's private ASs leaking here, by the looks of things, mostly. So there's probably some problem with a route filter somewhere, but you can identify where this is coming from, hopefully, and when it's been happening. So it's quite a sort of useful thing. They haven't had any spoofing problems, or they haven't run the spoofer software, so we don't know. We don't have that information. But they have a couple of unregistered prefixes as well. So there's an IPv6 prefix there. Quite often, those will be the ones that are unregistered. People seem to forget IPv6 for some reason, but yeah, you can kind of highlight that. And then for RPKI, they've obviously created some rowers for some of the prefixes, but there's 78 they haven't. So what we do here, we provide a link to RPKI, the RipeStat widget, so you can go and check in RipeStat which prefixes don't have rowers created for them. In fact, RipeStat checks a number of things, but that's just one of the things. We didn't really want to recreate the wheel there, so we just provided the link. And then you can look at the history as well for this particular network. So it looks like they've had a number of incidents sort of over the past year, and you can sort of see their track record with respect to all the actions. So actually, they have run the spoofer software earlier in the year, and it looked like they weren't they were filtering spoof packets. Coordination and IRR, they looks like they're pretty good. So really, it's just these sort of bogons and the odd route leak has we've been seeing. So that's a really brief overview. So let me switch back to the presentation. Yeah, and I put some of these screenshots in here. This is just in case the demo didn't work. It's live. Yeah, you can see the RIPE widget, the RIPE stat widget there. The current access policy is that if you just go as a member of the public, you can only see the global, the regional, and the country aggregated data at the moment. So only Manners participants have access to the detailed data about their networks. There's a number of reasons for this. This is because there are still some false positives. We're actually trying to encourage networks, work with networks to encourage them to improve their routing security. And there's some big offenders out there, but we've actually been working with them directly. So we're not really out there to just embarrass and name and shame. It's about working with networks to improve. And actually, even some of the worst offenders are really positive about using this tool, and they've used it a lot and have actually been making progress towards eliminating a lot of these problems. So we're not into sort of embarrassing organizations. But you can, if you're interested in joining Manners and you've got some issues, we can create an account for you. So you can look at your own data and work through that to help you improve your network. And we also could give accounts to a number of partners. So we have some researchers, network researchers working on this. There's some other, for example, CSERTs would be one example. We can give access for all of their constituents, so they could look at their network constituents and have a look and see how well those people in their customers or their constituents are doing routing security wise. It's not something typically that CSERTs do, routing security, but that's something we're also trying to encourage them to adopt as well. And actually, there are some good reasons for 100% non-100% conformancy. For example, bogons. You have these things called administrative bogons, where they've actually been assigned and they're being advertised by the network to which they've been assigned. But for some reason, there's an issue with the RIR. They may have lost contact with the RIR or not responded to a communication, and they get marked as bogons even though they have been assigned to those networks. And this does show up on the observatory. But at the end of the day, all of this data is public. It's sort of spread around in different places, but if people are really interested in digging the details for this, they could find it in various original data sources. So if you're interested in implementing Manners, we actually do have an implementation guide, which was actually published as RIPE 706 as well. So you can work through action by action and look at the configuration examples for some of the things that you may want to do. And then really just briefly, before I finish, we have, it's been quite a good year for us, well, good for Manners, let's say. So we're nearly up to 500 ISPs that are participating. There's nearly 60 IXPs involved in the IXP program, and even though we've just started the CDN program, that's been growing as well since April. Okay, so that's just about it. If you're interested in participating, please look at the Manners website. If you're interested in having an account on the observatory, please contact me. Just drop me an email and I can create an account for you. But yeah, we would definitely encourage networks in the ENOG region to join. And it looks like a lot of the networks are already pretty much conformant, if not conformant. So I think this is by no means a region with a lot of problems by the looks of things. So we would definitely encourage you to take a look at this. Okay, so that's it from me. I don't know if there's any questions. And I'm not sure where I looked for the questions, even if there were.
All right, thank you very much, Kevin. Thank you very much for a very interesting presentation. And we move on. And our next speaker this afternoon is Paolo Lucente.
Hello, can you hear me?
Paul, I gave you speaker.
Yes.
Right?
I'm finding my presentation. Where is that? I'm sorry, I'm trying to find the right screen.
So Paolo, if you're using Safari, you will not be able to share your screen there, I'm afraid.
Yeah, no, I'm using Firefox. It's just I don't find the right. Oh, it's saying error something. I think I have to reconnect. I'm sorry.
If you use Firefox, you when you press share your screen, you got window with drop box where you should choose the application.
Yes. I found it. Let's see. Oh, okay.
Oh,
perfect. Do you see my screen, right?
I set your timer till the coffee break, so you can.
Fantastic. Okay.
Top of your screen.
Thank you.
This timer.
And you see my screen, right? I can see it myself. Fantastic.
Yes.
Fantastic.
I see your screen.
So
and I hear you.
Fantastic.
Up to you.
Okay. So good afternoon. I'm Paolo Lucente. And you may have already noticed that technology is not my forte, right? But despite that, I am the author of pmacct, which is a software. I will explain what it is in the rest of the presentation. And this will be a very high-level introduction to the software. So if you're already familiar with pmacct, probably this will be, content that you already know, and maybe you want to grab a coffee instead of hearing to you. But very importantly, like after this presentation in the next session, if you want to hear about some more concrete use case of pmacct, I believe that Alex Asimov from Yandex, he will be presenting a use case that involves also pmacct for some more detail about the software. A little bit of introduction about myself. I am, yes, Paolo, and I have been collecting network telemetry data for the past 15 years, working mostly for large network operators and also for one vendor. The service provider industry is really in my DNA. I come from it, and it was one of the motivation to write pmacct, coming from operational needs, many years ago. Here you can find also, my social media, of course, a different username for every social media, because why consistency is important, right? And if you are listening to the, Russian language streaming, I didn't learn Russian yet. You know that I am not alone here today. So I would also like to introduce Alexei, who is providing the real-time translation. Alexei, you are great. I cannot hear you, and I hope I will go. I will behave throughout the whole presentation, going at the right pace, and my Italian English is understandable. So let's go. Let's start with the real content. So you can see, pmacct here. I hope you can see also my mouse. pmacct would be this, box at the very center with this octopus looking at you with the angry eye. Why the angry eye is because, nobody can really spell pmacct, and depending on the culture, they spell pmacct in a very different way. And so that octopus a little bit hungry. And you can see that there are two main sides in this slide. There is one side where there is data sources on the left-hand side. So libpickup, netflow, sflow, but also BMP, BGP, IGP. And on the right-hand side of the slide, you can see in blue, a number of backends, right? So relational databases, flat files, message brokers like RabbitMQ and Kafka, memory tables, and things like that. So pmacct would collect the data from a supported or a number of supported data sources, like we will see, and it will write it to a backend. And of course, it can, as part of its processing, it can do some enrichment. It can, there is the data reduction techniques, and essentially there is also some sort of intelligence, right, in the software. It's not just reading and writing. And then you can see also that there are some violet boxes, because essentially with when collecting traffic flows, essentially pmacct can also replicate them. And when collecting libpickup data, so when sniffing data, it can produce sflow or netflow out of it. So it can act as a probe and as a replicator other than as a collector. So let's start with some simple use cases. So what are typical use cases for pmacct? Would be like, you collect netflow IPFix and you write it to flat files. You can collect the sflow and replicate it with the T plugin and distribute it to other sflow collectors. You can collect the BMP and send decoded BMP data to Kafka. You can collect traffic, off of a switch or off of a router with libpickup, and sniff traffic, or traffic is passing through the box where pmacct is running, because it's a router, it's a firewall, it's a NAT, and whatever, and you can produce IPFix data out of it. And of course, you can complicate the situation as much as you like, right? So you have one single daemon that is collecting, for example, netflow or IPFix data. The very same daemon, the very same instance, it's also BGP peering with your routers. And so what is doing this instance? It's correlating the NetFlow with the BGP, what it means correlating. It means that you suddenly are able to know how much traffic, which flows, right, are for which AES path or for which BGP community, for example. This means, correlation, right? So you take an information that you don't have in BGP and information that you don't have in NetFlow, but you can, do a lookup one to the other, into the other, like a flow, like the IP destination of a flow into BGP. And now suddenly you have the amount of traffic for AES paths, for example. And then essentially, once you have done this correlation, this enrichment, essentially you can, aggregate the data, right? You can leave it as it is. You can aggregate more or less. PMSCCT really exposes you to, all sorts of primitives, layer 2, layer 3, layer 4, BGP primitives and things like that. You can build your aggregation and you can send it, for example, aggregated in some way to flat files, in a different aggregated way to MySQL. At the very same time, you can also take the raw BGP feed, of course, decoded for you, and you can just send it to Kafka, right? Just one of the many examples of a slightly more complicated scenario. So I mentioned a couple of times already, message brokers and Kafka and RabbitMQ, but what is the use case for message brokers? So you can see that, you have, I would say that the de facto standard, it's not a standard, but it's very widely deployed message broker is Kafka. RabbitMQ was a little bit more, widely deployed in the past. Now it's a little bit losing track, at least that this is what I can see from the PMSCCT user base. And essentially, so PMSCCT as a driver for Kafka and then as a plugin for Kafka, and also many other databases, and I'm sure that you recognize one or multiple of the names over here. They also have, let's say, a plugin or an ingestion for us. They support ingestion from Kafka. So suddenly, as a PMSCCT developer, I have to develop and keep up to date, just one plugin. And with that one plugin, like the Kafka one, you get access to a number of different databases of your choice, right? And then what is the great thing about these databases? So these databases would be the ones that you see mentioned here, Elasticsearch, Druid, ClickHouse, right? So they would be all part of this NoSQL movement. Sometimes they are termed like big data, column-oriented databases, time series databases, right? And so the nice thing is that they can deal with a lot of data, which is much more than a traditional relational database. Of course, that is because you drop on some functionality like the relational one, so you can deal with much more data. Like there is a lot of great engineering, but in the end there is no magics, right? And this is very great and very compatible kind of database for flow analytics, for BGP analytics and things like that. Another great thing about these databases compared to the old relational databases is that if you remember like 10, 15, 20 years ago, like if you were putting data in a relational database, then the data was just living in there, and then in order to query it, you really had to design your own user interface. Whereas these days, you have the luxury that, there are really tightly integrated stack like the ELK stack or the TIC stack, right? Where essentially you have the possibility, there are very highly integrated, UI with the database, right? You can see 3 of them. Also this, I believe it's 3 names that you have heard, like Grafana, Kibana, Apache Superset, right? That, if they are not totally entirely visual, they just provide you the right framework to query the database. So you have only to write queries, and then the visualization, all the magics of visualization, it's made for you. And I think this is a great enabler for it's a great enabler for data exploration, right? Something that we didn't have like 10, 15 years ago. Now, this is another view of just the slide that I have already presented, right? So what you can do with, so we said, what is the role of message brokers? Now let's expand a little bit, let's see yet again the bigger picture. So what I was explaining in the previous slide allows you to do a pipeline for network analytics, right? And here you have two views, right? So you have one, layered view here where you see that you have the network, you have a data collection, and then you have, typically these silos that, of course, you can correlate with each other, and then, you can send this data to big data and analytics, which would be, then the upper layer here. And then on the right-hand side of the slide, you have this, workflow here, where again, you have network, you have collection, you have the broker. And here it's something interesting, right? Because you can send data into a message broker, like Kafka, for example. You can send it directly into a database, or the database can consume directly from the message broker. Or the other possible way, it's this other one, the long route, let's say. So data processing, again, in a message broker and then in the database. And this data processing, it's, you can call it data processing, you can call it post-processing, you can call it a transformation layer. It's essentially a layer in which you can do further enrichment of the data. You can do, so further enrichment, correlation. Examples would be like you can, correlate flow data with a billing system, or you can correlate flow data with SNMP. You can do rescaling of flow data and for better accuracy and things like that. So you have this layer and, message broker, data storage, then analytics, right? And in the end, who is consuming from the analytics would be either human or machine, right? So you can have all one way, which is data exploration. So it's UI and self-service analytics and things like that. So essentially, people really get access to a data cube and they can really query this data cube. Or of course, you can make dashboards for them. Or the other way, it's a machine, which starts with the simple stuff like, reports and alerts, but it could go as far as machine learning as well. Use cases by industry like pmacct exist since 2003, and essentially, I will just comment very little this slide, like there are a lot of use cases that are covered and that they have been covered over the years. And essentially, every corner of our industry found, a use case for pmacct. It means it's a very flexible software. On the other hand, with flexibility comes complexity. So it means also, a steep learning curve. But I would say that once you master pmacct, I think you can do very nice things with it. And you need any help, I mean, I am always here, super happy to help you. So some non-technical facts about pmacct, it's that it's as I was saying, 15 plus years old project. You can't spell the name after the second drink. It's free, open source, and independent. At the end of the presentation, there will be also the GitHub link where you can really go and check out the code and things like that. It's under active development. Like if you go on GitHub, the last commit would be like as of yesterday. Innovation has been introduced and is being introduced, right? So you just imagine that, in 2009, for example, or 2008, 2009, nobody was doing in the open source space this flow to BGP correlation, for example, right? And innovation today, it's being introduced in two different ways. Like one way is just to keep introducing ideas, and the other is by closely following the relevant standards at IETF and implementing them and things like that. So that would be like the whole streaming telemetry part, the BMP part, and things like that. It's very well deployed around service providers, also large service providers, also OTT. And as I was saying at the very beginning, I mean, I come myself from the service provider industry. So, it's a very peculiar industry. People are they have really eye to the detail. It's scalability. It's very much, something to pay attention to. So it's all of this, it's part of the DNA of pmacct. Some technical facts, like it comes pmacct with a pluggable architecture. It is easy to add new data sources or new backends. You can correlate data sources. So natively supported data sources would be flows, BGP, BMP, what we have seen a few slides back. And external data sources can be correlated via tags and labels. Here, what I would say is that, like external data sources, you can either, let's say, merge in the exercise, you can correlate in the exercise via tags and labels inside pmacct, or as I was saying previously, you can do it later in the pipeline, like in the transformation layer. Whereas I would say that there are some correlation, like for example, flows with BGP, that I would still recommend it to be done inside pmacct because you need a lot of efficiency to do it at scale. And pmacct does it in a very optimal way with multi-threading. So it really limits the amount of the inter-process communication. And it's much better done, like you are much more efficient in resources than if you do later in a transformation layer. In pmacct, there are data reduction techniques because, especially when we speak flow data, there is tons of data that you receive from the network. So you can aggregate the data, you can filter, you can sample. And then, as I was saying also before, you can build multiple views. When I was showing the complex use case example, you can just collect data once, and then you can build different data sets from that one same stream of collected data. So you don't have to run multiple instances to produce different data set, right? So for example, you can go totally unaggregated. You can read network traffic and send it totally unaggregated to flat files for security use cases, or to message brokers for big data analysis, which boils down again to security, forensics, and other use cases like that. Or you can aggregate it in some very specific way. And here I provide an example of a very specific aggregation that maybe will produce a few thousand tuples per 5 minutes, right? So ingress router, ingress interface, BGP next stop, peer destination AS. And then you can send that. That's still an amount of data that is manageable by a relational database. And for example, this is a fantastic aggregation to build a traffic matrix for capacity planning or for traffic engineering purposes, right? And you can do all of that just collecting all the traffic just once. And of course, like I was saying also before, I'm just expanding on that, you can also do analytics against each of these, data sources, individually, right? So you can just say, I want to use pmacct just as a decoder, and the intelligence, I want to put it later in my pipeline somewhere. And so you can just send all of this data not correlated. You can just send it to your message broker, to whatever backend you like, and you can do it like real time, like message by message, or dump at regular time intervals. Like every 5 minutes, you do, just a dump of, the whole data. And of course, when doing the dump at regular time intervals, especially when you speak BGP, BMP, there could be some state compression, right? So you may have had flapping, for example, in those 5 minutes, and you are not going to catch it, right? Because it will be always, overwritten, and so you will just catch that a route is there or it's just not there. For catching things like route flapping in control plane protocols like BGP, you need really the streaming real time. So pmacct is also ready to scale, horizontally. Why is that? Because you can build the smartest software you want. You will always hit a limit. So the only way to break the limit is just to scale horizontally. So within a single system, a single Linux system, for example, you have this SO reuse port. SO reuse port is available on any recent Linux or BSD kernel and allows to many daemons that are run from the same user to bind to the very same port and same IP address, and then the kernel will start load sharing among them. And you can also scale horizontally among multiple systems. Like pmacct provides two facilities: the T plugin, which is UDP replication, very sophisticated. Like you can add, change, remove receivers on the fly without restarting the application. You can do a little bit more sophisticated load balancing, or you can be also selective, so you can replicate based on filters. And then, of course, you have BGP cross connects, which is essentially TCP proxying for BGP. And in the next slides, we will see where T and BGP cross connects come into the picture and why they are useful. So everything started like this. Like you have a telemetry collector backend, fantastic, easy peasy lemon squeezy. But then, over time, you may get, more information, right? So it starts like, okay, let's get some NetFlow, and then, you can get also BGP data. You can get event logs, like NetFlow NEL is network event logging, if I'm not mistaken, and it's essentially, the carrier grade NAT, like send, or for example, firewalls, sending, data about events, about NAT events, about filtering events, and things like that. And so already this much more amount of data, especially the event logs, they put more pressure on the collector. So you obviously need, multiple collectors, to make this scale at pace. And so essentially, you would be tempted to just throw a little bit more collectors at it, collector 1, 2, n. But there is one big problem here, which is that imagine that now you have a new router Z. You are adding router Z to your network. So to which collector are you going to, add this router Z? It's to collector 1, to collector 2, to collector n, or whatever. So it's there is a problem in general in exposing the internals of the cluster, of the collection cluster, to the network. So here is where, BGP cross connects and T like come into play. Essentially, it's like a layer that you put in between the collection cluster and the network. So that essentially, and of course, the BGP cross connect and the T, you can just make them high available. You can anycast them, and it's just two pmacct specialized pmacct instances that just provide this service. So TCP proxying and UDP replication, and essentially you can just at this point you can have templates in your routers. You just say, I want to export, when I have a new router, I would just want to export telemetry and the BGP peer with this whatever IP address, and then all the rest is figured out by anycasting and high availability on those very boxes. And then inside those boxes, you can do the whole, you put all the logics, to scale out within the cluster based, for example, on load. You can, or based on geography and things like that. You can put the whole logics to, direct the right feed to the right collector. So this is my really last slide, and I see I am on time. So what are the works in progress in pmacct? It's support for BGP-LS. Why? Because at the moment there is an IGP plugin, and this plugin supports mainly supports ISIS. So OSPF is not supported. Also, ISIS, there are some limitations. So BGP-LS essentially unlocks the full, potential of having, IGP information in pmacct. Keep pace with the BGP, with the BMP protocol. I am also myself personally very involved in the development of the BMP protocol at IETF. I think it's very useful to have monitoring playing for BGP, and so pmacct is following the latest and greatest versions of the drafts at IETF. And also make progress on, the counter proposal, let's say, let me call it counter proposal, or streaming telemetry from IETF. So that would be Young Push, essentially, right? Which is, a way to standardize, the transport layer and the encoding layer to transport young modeled data. And then another, the last big, item, I would say, of the visible features is the increased clustering elasticity. I spoke in the last few slides about clustering. Elastic clustering, it's different from just clustering. It's at some point you just add a new collector, and there is some sort of magics that is going to take care of all the details, right? So you just add a new collector, and the traffic rebalances automatically, right? So this feature is not there yet. I would say that what is there right now, it's a support for a Redis cache, and this support, what it gives is gives all the nodes, a knowledge of being part of one single cluster, so gives visibility. Then what will happen is that some perhaps telemetry information will be exported there, so that some decisions can be made in the replication layer about where to direct the feeds, the specific feeds or new feeds, if a new router is added for BGP peering and things like that. So this is a big work item, also a little bit complex, but super exciting, because the moment in which you can make clustering and also as much elastic as possible, then essentially, scale is pretty much infinite. I leave you with some further, with this slide that you can review at your best convenience later, if you are interested in further information about pmacct. And with that, I thank you very much for your attention. And I don't know if you have any questions for me.
Thank you, Paolo, for your presentation. I see at least one question from Alexander Azimov. I give him a microphone.
Okay, thank you. Paolo, thank you very much for the report. I'm the user of pmacct. Already enjoys the benefits that you implemented. I wonder about the BGP link state. So you are telling that you are going to provide support for this.
Yes.
Already it's the GitHub, or
Not yet. It's something on which I will make progress after ITF, because this week I was busy with ITF, so that means always BMP for recently. So after the week of the ITF, I will start the development of BGPLS, I think, and I hope to have something already workable by the end of the year.
Okay, and a connected question. I cannot remember. Does pmacct support BGP label unicast?
Yes. Yes. The families supported are the VPN v4, VPN v6, IPv4, IPv6 label unicast.
Okay, great. Thank you.
My pleasure.
Next question, Dmitry Sigulov. Please. Dmitry.
Hello, Paolo. Thank you for the presentation. I'm now reading your GitHub publications and documents. Is there anywhere a description of the internal structure of your app? Shall we go to the basics, or do you have a description somewhere where we can read it?
The internals, yes. There is actually really a document on GitHub. Like, there is a document section and there is a file called internals. And with that, you can, read all the super basics, how, for example, you want to create a new plugin or you want to create a new data source. And of course, the ultimate, source for this information is me. So ping me. I am always friendly, always available. I'm glad to help.
I see no more questions. Thank you, Paolo, for your presentation.
My pleasure. Thanks very much for having me.
And we are going to close our first session of the day. At this point, let me remind you that our next session begins in half an hour. It's going to be 3:30 p.m. Amsterdam time, 4:30 p.m. Kiev time, 5:30 p.m. Moscow time. And our first speaker is going to be Alexander Azimov. He's a great speaker, by the way. Come and listen. And 1:15 in all time zones, please come and join us for the Kahoot quiz. Thank you and see you soon.
This quiz won the popular vote by millions. Period. So, live broadcasting from the Garden of Eden next to a tree of apples. So, welcome to the 4th Kahoot quiz. I mistaked yesterday. I said the 2nd, but it was actually the 3rd, and this is the 4th at ENOG 17. My name is Gerardo Vivieres, and you may remember me from classics like I Quiz You to Eternity, or My Quiz, or Your Quiz. So join us for fun and learning at www.kahoot.it or use the Kahoot app on your mobile phone. Don't forget to include your register number and your nickname so we can contact you to send you your prize. We have ENOG 17 t-shirts for the winners. Today's quiz is sponsored by the Coordination Center for TLD.RU, and the theme is rooting. Now, let's hope that today you don't play like this animal. So today's pin is 9839499. If you never played this game, let me quickly tell you how it goes. You're going to see a question and 4 possible answers. You're going to have to click on the right answer, the fastest of them all. If you are the fastest, you get the most points. And the people who click on the right one but are not so fast, they'll also get points, but not enough to win. You'll have to click on all the right answers to win. We have 14 people signed up. Go! No, not yet. 15 people. Should we go? Go! Okay. The voice says go. So let's start. In 3, 2, 1. BGP peers, start a session by sending a blank message. Is it a hello message? Is it an open message? Is it a peer with me message? Or is it a what's up? And the right answer is an open message. The hello message is from SMTP. Learn your protocol, mister. Symbol 149 at the top, AI281, QWSX, TASIC, and Ilya. On to our next question, which is, which of these came first? Was it IPv6? Was it IMAP? Was it RPKI? Or was it BGP4? If you know the answer, you are old. It was IMAP. IMAP came before any of these other protocols. On to our next question. Symbol 149 at the front. ENOG, Mensky, AI, and KWSX. In RPKI, what do you call the software that validates ROAS? What is the software that validates ROAS? Mother, validator, rootinator, or validator? Which one of these is the software that validates ROAS? Yes, good. Validator. You all know your RPKI well. Let's see if you know the next question. Symbol at the front, QWSX, Mensky, Sergeyev, and TASIC. And the next question is, what can ROAS help protect the network from? What can they help them protect the network from? Is it speeding cars? No. Bad choices? Of course not. Hijacks? Intrusions? Malware? Which of these? I have to know. If you don't know, press randomly. And the correct answer is hijacks. Our ROAS cannot help you from malware, unfortunately. Ask the ITF to add that feature. Symbol 149 still at the front. Mensky, KWSX, Sergey, and AI281. On to our next question. Which BGP attribute is evaluated before the others to decide the best path?
Who was that?
That was me. Was it the origin? Was it the oldest path? Was it the MED? Or was it the router ID? Which of these is it? If you don't know, just press randomly any color. Everything is fine. You will know the answer by the end of this question in 1 second. And the correct answer is the origin attribute. On to our next question, but let's check the tables first. Symbol 149 still at the front. Joe 338, Klimarev, Mensky, and KWSX. Next question is, what is an NLRI? That was a long cricket. Nearly let Rudolph inside. Network latency resolution information, network layer reachability information, or network layer readability information. Which of these is it? That is network layer reachability information. Well done, people. We have symbol 149 still at the front. Joe 338, KWSX, Mensky, and Sasha coming up. On to our next question, which is, RPKI relies on the chain of what? Is it trust, trees, love, or trump? Yeah, I'd scream as well if I heard that. But what is that RPKI relies on? The chain of trust. Yes, you all got it right. That was so easy. Symbol 149 still at the front. Joe 338 coming quick. Mensky, KWSX, and Sergey. On to our next question. If we miss 3 consecutive keep alives, BGP will declare the neighbor alive, busy, needy, or dead. So if we miss 3 consecutive keep alives, BGP will declare the neighbor to be what? And the answer is dead. So if you don't send your keep alives, BGP will think you're gone. Symbol 149 still at the front. Joe, Mensky coming in quick, and KWSX, Sergey. On to our next question. We only have 2 more, so you better be quick. The last 32-bit AS number is the first one, the second one, the third one, or the fourth one. I have no idea how to say those numbers. But if you can pronounce them, I think you are the winner. Now, it'll take you some time to read those numbers, but if you're good at math, you will probably spot it. The right answer is the one in blue. And we can see that everybody just pressed a random number. Who wants to read numbers at this point in time? Let's go on to our final question. Symbol 149 still at the front. Joe coming in, Tasik, Mensky, and KWSX. Now, this is a head-on, neck-to-neck finish. Let's see what happens. In BGP, it is best practice to use a blank to establish a session. So, a directly connected interface, a monkey wrench, a loopback, or an AS number. No! Which one of these? Which one? No! And we're at the end. The answer is a loopback. Yes, it is best practice to use a loopback when you want to establish a session. Yeah, I knew that. And let's see, who is our winner? Number 3, we have Joe 338. Well done. Number 2, Sergey M. And number 1 is Symbol 149. Yay! Well done, everybody. Thank you all for participating. You're all winners because you all learned something. We will reach out to the winners to send them their prizes. I hope everybody had fun and maybe learned something new. We will be back again tomorrow, same time, same place, but different quizmaster. Prepare yourselves. Tomorrow we have a surprise guest quizmaster. So have fun, and let's hope that you learned something.
Приветствую всех, кто успел вернуться с Кахута.
Welcome.
Нам, конечно, сложно конкурировать с контентом
Welcome.
такого уровня.
Tomat, you're in the English channel.
So, sorry.
Once again, welcome everyone who managed to come back. It is very difficult to compete with Kahoot. We're not that much entertainment. However, we have high hopes of our next speaker. You must know him very well already. That's Alexander Azimov from Yandex. For those of you who have just joined us, and if you haven't been briefed before, please make sure that to send your questions. You can do it by either using the speech bubble below your name tag, or you can request the audio floor. And I'll remind you that all our sessions are being recorded and they will be published on the website together with the slides. Let me also remind you that the program committee will be very happy to receive your ratings of the presentations during the conference. We read all your feedback, we analyze your feedback, so please do not hesitate to share your comments and ratings of individual speakers and of the event. Now, over to Alexander Azimov. The stage is yours. I'm not sure your microphone is on. Can you check that? We can't hear you. I can't hear you. Neither can I. Can you make sure that your mic is on, Sasha? And what are your audio settings? No. There is still silence. We'll let you know. Oh, now, something is coming through. Very good. And I was afraid that we might be, we might have to go and look for a Russian Sign Language interpreter. Hello, colleagues. I hope you can see me and hear me and my slides. You can see my slides too. My name is Alexander Azimov, and in Yandex, I developed transport layer infrastructure architecture, sorry. And I'm also in charge of various security issues. Today, this presentation will focus on BGP security and new monitoring techniques and tools that become available to us these days. Now, how about this? We at Yandex, we try to follow best practices and comply with the best practices in the industry. Our address space, our prefixes are signed with ROA, and all row invalids, all routes with row invalids are rejected. We are also monitoring our own prefixes in the BGP world, and for this we use BMP and two RPKI objects, RAW and ASPA. And the more attentive listener might get curious at this point. Okay, we all heard about ROA. Maybe some of us are already using it even, and we even signed our address space with it. But what is ASPA? This is something that IATF is working on right now. They are currently building a new RPKI architecture object. Your provider signs or lists the customers. Only new customers are added. Old ones are never removed. And the quality of this object usually degrades. And this is something that's familiar to us via RIPE infrastructure. ASPA is similar, but it's different. ASPA is the object that's created by the client, in which the client, the customer, lists the providers. And as the signatory, the client is interested in maintaining this object updated, up to date. As to how ASPA works, there are similarities between ASPA and ROA. The object itself exists to do inspections. There is a pair of two ASs, autonomous systems. Is it correct or is it not correct? I will explain later how to use this function, but in general, you take a pair for the first number and you get the list of all valid objects. And from the second part of this object, you build a common list, a single list, and then you verify whether the potential provider is on the list of authorized providers. What does this ASPA object allow us to do? It detects leaks. We can detect accidental leaks, the leaks that are caused by errors. But if you complement it with raw mechanics, then you can also identify man-in-the-middle and other attacks. I will show you how it works. I will show you a case. But before we get to the case, we need to agree on definitions and terms. And I hope that I will not get you confused. If the circle is above a different circle, it means that the top circle is the provider to the circle which is lower. If the circles are at the same level, then the circles are peers. And the most important thing, arrows or lines. The lines or the arrows do not identify the direction of the route. Instead, they identify the inspection of ASPA pairs. Okay, let's take a look at scenarios. Here's the first case. Say we received a prefix from our client. We are in the AS number 4, and we need to make sure that the route that we received is correct. How can ASPA help? The routes that we receive from customers have an interesting feature. All AS pairs, out of which this route consists, must be associated with customer-provider, customer-provider, customer-provider pairs. Nothing else is admitted. If there is a peer or a provider-customer pair, then it's wrong. It means it's invalid, it's incorrect, it's a route leak, and there is a probability that we are sending traffic there, but there is no life at the destination. To the left, you can see an example of a correct or valid route. 1, 2, and 2, 3. These two pairs are valid. Therefore, the path is valid. To the right, you see a different case. It's the opposite. There is a route leak. S3 is receiving the prefix from one of the providers, and it's sending it to a different provider, number 4. Therefore, we use ASPA to detect this. We can check that pair 1, 2 is correct, it's valid, while the pair 2, 3 is not valid. Why? Because 2, autonomous system 2, doesn't have 3 as a customer. And that's how we can find a leak, a route leak, using such a simple algorithm. Now let's take a look at a more interesting case. We know that filters are applied to our own customers. Sometimes we would use them in case of peers, but this is a bit more complicated. But can ASPA be applied to paths that we are receiving from our peering partners? And the answer is yes. If it's a peering partner, there is no difference in the customer relations, basically. The path that we are getting from a peering partner can have pairs such as customer provider, customer provider, customer provider. And just like in the previous case, we can capture a leak that happened at autonomous system 3. Let's take a look at an even further, an even more complex case, something that wouldn't be possible without sets. Well, that is to say, with ASS, you cannot find round leaks if you are receiving them from your own provider. What is the meaning of having a set with a full view? But if you are using ASPA, you will be able to find those deficiencies. The route that we receive from the provider potentially can contain 2 segments, an uplink and a downlink, an upstream and downstream segment. And there may be some turning point. And the first pair, which becomes invalid, is not telling us completely that this is an incorrect path, but it tells us that we found the location from which all other pairs should be provider customer, provider customer, provider customer. So it's customer provider all the way to the turning point and customer provider all the way back. Here in the first example, 1, 2, 3, 4, this is correct. 4, 5, that couple, their peers, ASPA will return an invalid. Is this a problem? No, it's not a problem. It's the turning point. And after that, we need to make sure that all the remaining pairs are provider customer, provider customer, provider customer. And we can do it with ASPA. We know that 6.5 and 7.6 are valid. If this is true, then the path is also valid. Everything is fine with the path. To the right, you see an example of a leak. It all starts well. 1, 2, 2, 3, 3, 4 are all valid. 4, 5, as we have already discussed, seems to be invalid, but we know it's a peer, and we need to make sure that 6.5, is this 6.5, is this customer provider? Yes, it's customer provider. What about 6.7? Oh, 7 is 7 doesn't have 6 as a provider. It doesn't have 6 on its list of providers. And this is how we can identify the leaks based on the prefixes that we receive from providers. But actually, we can detect those leaks everywhere. ASPA and the object profile can be found here on these links. Their status today is adopted by the working group, and I hope very much that soon they will make progress towards an RFC. What does it depend on, this progress? It depends on the authors who are responsible for maintaining this document. I'm one of those authors, and the co-authors were all people, and in order for us to make progress, we need feedback from the community. We need someone to tell us that we are not making ourselves clear, and this is something that doesn't seem true. So I'm the one receiving those comments and reading them and reviewing them. We need all these documents to be readable and understandable, and I mean, there will be many users for these documents in the future. Now, in summary, what ASPA is. Potentially, it is a new RPKI object that can detect route leaks on its own, and in combination with RAW, it will be able not only to detect route leaks that happen by accident, but also it will be able to identify hijacks and other attacks in order to organize them in the middle attack. Well, you can fight it with RAW and ASPA. And maybe if we have ASPA and RAW, someday in the future we'll be able to claim that inter-domain routing is finally safe. But this is a thing for the future. ASPA is here, and now there was a proposal to use regular expressions. Those colleagues used information about the well-known providers. Later, they extended this functionality to analyze customer provider pairs. And it works. There are other major operators who are now using this mechanics. To my dismay, this solution right now is partial. Why partial? Regular expression is difficult to compute and to analyze routes that we receive from providers becomes next to impossible using regular expressions, because if you don't have primitives in the cycle, and usually in the policies we do not have the primitives to get to be able to analyze the turning point and to apply regular expressions is a major challenge. So it works well in tier 1 operator networks, but it doesn't work well in other type of networks. That's why Yandex found its own way. And in order to build regular expressions on our routers, we started with the BMP protocol as a pmacct, and we have just had a beautiful presentation from Paul on pmacct just half an hour ago. So we use that to analyze the routes with RAW and with ASPA, and as a result we got wonderful functionality outside of our own network. We can now monitor for the anomalies on our prefixes. I'll repeat myself. Sometimes, well, usually people believe that in order to monitor external anomalies external to your address space, you should use external monitoring tools, but it's not necessarily so. How does it work? What happens with your prefix? This is how it propagates. You announce it to peers, to then providers announce them to their customers. And then your prefix propagates around the world via a number of autonomous systems. But we know that not all autonomous systems provide good support to their policies. But even if someone was not clear in the policy, if there is a potential vulnerability in the policy, it should not result necessarily and it shouldn't necessarily result in an incident. If upstream providers can filter out the anomaly, there will be no problem. And yes, you can start with an incorrect policy, but traffic is traveling in the right direction. These are good leaks. But if your anomalous prefix begins to propagate, then there is a problem, and your traffic can be redirected to an autonomous system that will lose it. If your customer chooses this path, if your peer or your provider choose this path, will they send it back to you? Yes. But it will be sent to you as their new best, and it will be up to you to filter it or not filter it even though it contains your own AS number. So your neighbor will be reporting to you about the leaked paths that they received. So here is a problem. You can either reject it because it's invalid. On the other hand, we need to know about this path for analysis. And BMP fits the purpose very well. BMP doesn't ask you to rebuild your routing policies, to use some bypasses. But with BMP, you can get a feed of messages with information about all routes received. Autonomous System 2 will receive the path, which will have AS1, 3, 5, and then 2. And then we will find out why our neighbor is sending back to us a path with our own AS number. And this can be a perfectly valid situation. That's why you need to apply an SPA. How does it work? Before I talk to you about the real incidents that we managed to capture, we understand that in order to apply SPA, we must have some expert base. First, we must decide on the operators, on the number of autonomous systems that we can trust. We need an expert judgment. And I ask you to participate in the poll right now. I hope my chairs will help me to run the poll. My question to you is, how many SPA records do you need so that you can have a monitoring system that will capture route leaks? I can't see whether you started voting. Yes, we are voting. Good. Okay, then we'll make another pause for, I don't know, 20 seconds. And after that, I will show you one possible answer. Actually, there are many different answers here. Based on experience that we have in Yandex, to have a good solid monitoring where SPA is used to trace those leaked routes, you need 36. This is not a lot. And I can tell you that to find those autonomous systems that it wasn't very difficult to find those autonomous systems. And now a real case that we managed to pin down with our monitoring system. Our prefix was incorrectly redirected by our peering partner Megaphone to Cogent, and then Cogent sent it back to us. And this is how we found it out. Actually, we were receiving those messages from several partners. So we see a prefix and it has an AS path. And we look at the last number of the S. This is level 3. This is API transit provider, and it means that this is a path that's coming from the provider. We have different functions to process paths for the routes that we get from customers and peers, and a different one for the routes coming from providers. After that, we begin our analysis. Step 1, we need to understand whether Yandex Megaphone peer is valid. No, it's not valid because Megaphone is our peering partner. And in our expert judgment, there shouldn't be such a pair. Is the route incorrect because of that? No, as we have already discussed. It just tells us that here we have a turning point. A turning point doesn't invalidate the route. But after the Megaphone autonomous system, we should be looking at provider-customer pairs exclusively, which is not true. Because Megaphone, again, based on our judgment, it doesn't provide any IP transit services to Cogent. Cogent is a well-established tier 1 operator. I think that with this example, you understand better now how we use ASPA. Okay, and to finish the presentation, like I said, we signed our address space with ROA. If you haven't done it yet, I highly recommend it. We use BMP and ROA to identify route hijacks, and we now use BMP and ASPA to identify route leaks. We want to use the ASPA mechanics for filtering starting next year. We will be filtering not only from our peers and customers when we don't have customers, but we'll also be filtering from our providers. As to how we're going to arrange this, I'm sure this will be the topic for my next presentation. Thank you very much. I'm going to close the screen now and open a different screen to see whether we received any questions. I do not see questions. There is a question in the chat. Dmitry Burkov is asking, can you, what Jeff doesn't like about ASPA? Which Jeff? It's a difficult question. There are many, Jeff, is it Jeff or Jeb? Okay, we have, oh, Dmitry is here. Dmitry is here. And Dmitry will be able to clarify his question, but Vitaly Zubok was first to raise his hand. Can you hear me? Not very good, but I'm going to turn it up, turn the volume up. Is my understanding correct? It's the BGP subject that has to provide a list of providers. What about a good faith mistake? If there is a good faith mistake that results in a route leak, I understand that it's what you call a good leak probably, but what if it's a malicious user? Such a user can make unnecessary BGP announcements and make entries, invalid entries, false entries. Oh, no, not really. And yes, yeah, it's possible that you will see a list of that will be half the world long, like the providers from half of the world will be on the list. I will go back to my slide. Oh, there. Okay, how does it look like from the perspective of autonomous system 3? Yes, it can state that 1, 2, and 4 and anybody is its customer, but the check that we are running, we are checking the 2-3 relationship, 2 to 3. The source of leak and the object creator are two different entities. Autonomous system 2 must authorize autonomous system 3 and be its provider, and only after that 3 can safely report a leak. Can you hear me? In your practical example, in your practical case, if the source of the leak is megaphone, okay, what if it's not megaphone? What if it is an abuser who got access to BGP, to be megaphone BGP route? Okay, again, another good question. For megaphone to perpetrate a leak unnoticed, it needs to have 2 records, one signed by Yandex and the other signed by Cogent. And it doesn't have access to our records. Yes, it's possible for megaphone to generate a leak. Well, not megaphone, obviously, but okay, someone whoever is in the place of megaphone, the trespasser, anyone, I don't know, an attacker. But for this route to be invisible, not to be detectable, a leak itself is not enough. You need to have control over the records of your neighbors. Well, actually, not just your neighbors, you need to control more records. Okay, I understand. Thank you. Thank you very much for this clarification. I have another question. The computing difficulty, I think it's linear, right? This complexity, it's linear. Yes, yeah, it's linear. If the path is valid, we will go through it completely, all the way through. I would really like to hear the explanation from Dmitry. Well, someone sent us a comment saying that it probably is Jeff Houston. Oh, I've been talking to Jeff Houston, and I didn't get the impression that he was against this idea. Yes, he had questions. And his first impression was that this idea was similar to GP. So BGP, I don't have time to explain what that is, but after I managed to explain that here we deal with a completely different mechanism. Since then, I believe Jeff to be positive and optimistic about the SPA. Of course, I can't speak on behalf of Jeff, and maybe you should address this question to him. But my impression is that he's enthusiastic. And Dmitry Burkov switched off his mic, and we don't know whether he still wants to talk. And I don't see any other questions. Maybe I don't see him on the list of participants. Maybe he got disconnected. We are running out of time. So Alexander, thank you very much for the presentation. You stirred our discussion, a friendly discussion. I'll remind you that you can request an audio flow, or you can send your questions in writing into the chat. Do not forget to introduce yourselves. And yeah, if you have additional questions on this presentation, you know where to find me. You have my contact details, so please get in touch. And I ask you kindly to please send us feedback on the documents. And during the poll, in the poll, everybody said less than 50. Less than 50. We have a very competent audience. Yes? You were saying? Oh, my very last comment, I can tell I'm looking at the clock and I see that we're behind the schedule, but for ASPA to work, the number of autonomous systems that must support filtering is also tiny. It's very, very small. Not more than 10. Thank you. And I will remind the listeners who are following us on YouTube or on the Miteco platform, and the program committee continues to request you kindly to rate all the presentations. We need your input to prepare the programs of our future events. And now, let me introduce to you our next speaker. That's Maria Kolesnikova. She is with .ru CCTLD. And this presentation is on universal acceptance. And news and challenges. Maria, welcome. Good evening, good afternoon. I hope you can hear me. Yes, we can. I'll try to share the screen. It's not that simple. But what is? Okay. Yesterday's training taught me something, and I managed to do this. I hope you will all enjoy this presentation. It's not very technical. but I will still be referring to some technicalities. Anyway, and your questions are welcome too. My name is Maria Kolesnikova, and I represent the Coordination Center for .ru and .rf, the CCTLDs. Today we will talk about universal acceptance, what the news are, what is the news, and what the challenges are. As a registry for top-level country code top-level domains, we every time there is an opportunity, we talk about domain names, and that's why, again, today the topic of this presentation is domain names support. Over the recent decade, the DNS system transformed itself. You know that more than 1,200 generic top-level domains came into being. Some of them are ASCII domain names, 3 to more characters. And then there are also internationalized CCTLDs. And even before we had those 1,200 generic top-level domains, we already had internationalized country code top-level domains like RF. RF was one of the first top-level IDN in the internet. It was registered on the 12th of May 2010, and this year we'll be celebrating 10 years of .rf. So today in the world there are 156 IDNs, IDN CCTLDs rather, and inside Cyrillic script there are 17 IDN TLDs. 9 of them are national, they are country code, and 8 are general. They were registered under the new TLD program of ICANN. This TLD list is not static. Domains come and go, and it makes sense to follow all these changes. And if your software provides for some inspections or checks of the domain names, it makes sense to use the most up-to-date list of top-level domains. What is universal acceptance? It is a concept that assumes that all internet-facing applications, devices, systems must support or accept all domain names and email addresses without any discrimination. There are 5 criteria of universal acceptance. These criteria are responsible for, well, they apply to domain names and email addresses, and they all must know how to work with those identifiers, accept, validate, store, process, display. These are the criteria. When we talk about the problem of universal acceptance, UA, these transactions, these operations, they must all be performed correctly. Universal acceptance can also be considered as a broader concept. It is a regular theme of various international conferences and events. Universal acceptance is seen as an aspect of inclusivity of the internet, of the inclusion, and also providing access to those users who are not yet online or who have difficulties of using the internet because they don't speak English, and that's why we need to provide those users with internationalized domain names and email addresses. What are the main categories affected by your readiness? Domain names, especially in Latin characters, the ones that are recent, that did not emerge a long time ago. Then there are domain names that are longer than 3 characters, and also internationalized domain names. And there are a top level and also second tier or lower tier domain names, and also email addresses. Please bear in mind, especially when you start, diving into this subject matter, it becomes news for many people. You don't notice it immediately, but you will see that following @ there is a domain path in the email address, and here we are supporting domain names, also internationalized domain names, and the native script on the basis of RFC. They are supposed to be processed with Unicode, but in the local part of the email address, what comes before @ not only Unicode. According to RFC, any Unicode characters are admitted, and this is a major difference. For the local part, Unicode algorithm does not apply, so you should not forget about it. And all RFCs today, they exist, they are developed, they are known, and when we say that there is a problem of universal acceptance, what we mean to say is existing RFCs are not implemented, they are not executed in software or in services. These are the main target audiences or stakeholder groups who are today involved in universal acceptance discussions. They are developers of technology, developers of programming languages and frameworks and other tools for developers, and then there are various suppliers of software and services, email administrators, providers of email software, and also system administrators who are responsible for updating the software and the settings of the software. And one of the key stakeholders here is the government policymakers, who are seen as drivers of demand, shaping the demand for universal acceptance by supporting those identifiers in their own services by using special software that's developed for government needs, and also by using UA in e-government portals. Here, basically the same idea is repeated again, but in different words. What are the benefits of UA for all these different stakeholders? I have to say that email internationalization today receives a lot of attention and support, and I'm talking to you today specifically for this reason. That is to say, I want to urge you, if you are developing, if you have your own services or devices or systems, please be mindful. It's a trend, really, that today that matter has been actively discussed, and at the international level, major developers and vendors are being stimulated, motivated to implement universal acceptance. And you can join the trend. The idea is to provide support to email addresses with Cyrillic characters on your websites. That is to say, in your registration forms or subscription forms or feedback forms, and also for your intra-corporate communication, your corporate communication, and also all the support services or help desks that you have for your customers. Because if there are clients who have .rf domain name, they have email, an email address in that zone. We don't have many, about 20% of the total audience in our statistics, but we have those clients, and they use this kind of email because today they do not have any other way to communicate with you, because most likely your website doesn't support the Cyrillic email address. Now, how big today is universal acceptance? How much do we have of it? There is a link at the bottom of the slide to the report of the Universal Acceptance Group. This is an international group which is established at the initiative of the community back in 2015. Today it's part of, well, it receives organizational and financial support of ICANN. And here, I mean, you can see on the slide, you can see all the key numbers. 9.7% of email servers are configured to support local languages and scripts. 11% of the popular websites globally support email addresses with Unicode characters. 98% of popular websites know how to work, and they know that there are new top-level domains, the short ones, 3 characters. But okay, there there is progress. The link to the complete report is given below. Here, you are looking at Russian statistics. These are popular Russian websites and how they support internationalized email addresses. If you take a look here, this part, Russian websites support fully Cyrillic email addresses. Only 19% of the Russian popular or top Russian sites support fully Cyrillic email addresses. Again, another link to the report at the bottom of the slide. This is a report in the Russian language. People at the Coordination Center at the CCTLD, we did this special check on Cyrillic characters. You can find our findings in there. We are in the second place among all countries in terms of support to email in the national language, and the first place is taken by Germany. Here is the list of software that is considered to be EAA ready, open source solutions, proprietary solutions. There are services that know how to work with internationalized email addresses. Google knows how to send and to receive those addresses. If you have a Gmail account, then you can send me a message at Masha@KC.RF. I will get your letter and I will be happy to respond to it. Out of the bigger vendors, there's Microsoft that provides support in Outlook and the Microsoft Exchange server. And just in September, Apple announced a support to a long list of scripts, including Cyrillic script in iOS 14. So things are moving, it's underway. The developers are implementing new services slowly but steadily. Here you can see the list of services that are ready and also not EA ready, not UA ready. My colleague from Yandex, well, I ask you to look at the slide and read that Yandex Mail does not recognize Cyrillic yet. That is to say, Cyrillic email addresses. We did quite a thorough study, and in this report that you see at the bottom of the slide, you will be able to find more details about what we checked and how we checked it. There were many parameters, and here are additional links to UA readiness measurements. There is a report on email addresses acceptance. I mean, more reports are under development. I refer you to USG website. We checked programming languages, frameworks, what happens in the command lines, and how popular websites support an internationalized email address and how browsers recognize ID and domains. There is a framework to check software and services, and it describes a general approach on how you can set up a test for your service, for instance, for universal acceptance. It doesn't give you a methodology of test. USG is working on it right now, but it will give you an idea, a general approach on how to go about it. At the local level, too, there is a lot of outreach activity and other initiatives. This year alone, Coordination Center organized many events to celebrate the DataRF 10 years anniversary. There was the Поддерживаю DataRF initiative. We supported all UA documentation in Russian into one place. On this website, you can also find a list of software that is UA ready. It's a dynamic list. We started with open source software, but it will be complemented with proprietary products too. There is a bug bounty program as well. If you want to take part in testing, you can add your own or some external third-party products into the list, and you can indicate which bugs that those products have and how they are not universal acceptance. So the program will be running until the end of the year. We also organize trainings to support administrators. We organize live demos of how EAA work, how technically this is implementable, and we are preparing a UA readiness training for Java developers at the end of November. Hopefully, there will be a new course, and if you want to join it, if you are a Java developer, please sign up for this training. We offer the UA case for hackathons. One of the big Russian hackathons, the Digital Breakthrough, it's called. Our case was chosen by about 19 teams. 13 of them were shortlisted. So I have to say that in just 36 hours, the developers who knew nothing about universal acceptance, and this is one of the problems, biggest challenges of universal acceptance, that very few developers know about the very concept. They are not familiar with the RFCs. They don't know how to check the email addresses and domain names. But these guys managed to verse themselves in UA in just 36 hours, and they even produced a patch for the email server. And the students who participated in the CTF summer school, the students produced a website. Their task was simpler, and they had very little time, but they did a great job. I loved attending those hackathons. Universal acceptance at the local level, since ENOG is a regional forum and we have colleagues here from different countries, we have local initiatives for the CIS and Eastern Europe in universal acceptance. Right now, this initiative has experts from 7 countries: Armenia, Belarus, Georgia, Latvia, Russia, Serbia, and Ukraine. We work together, and at the regional level, we're trying to promote the idea of universal acceptance and to somehow assist with implementation. There is also a Russian working group on universal acceptance. If you are interested and you really want to support us, please get in touch with me. I will give you all the information. We'll be happy to welcome you as a member of the working group. Here are the 3 main areas of focus: a technical collaboration with support developer system administrators. We can provide consultations. And then there is raising awareness and organizing global outreach for the end users, for the businesses, for the public in general, the mass media, and there is the public sector engagement. So that's it. This is it. Here are my email addresses. If you would like to test your Google account, then you can send me a letter at masha@kc.rf. Thank you, and we have questions. Hi, Masha. Bug bounty. Well, traditionally, this is not just finding bugs. What about rewards? Well, I think it's something you should have spoken about. Yeah, well, there is a reward. Probably we don't pay too much, but yeah, it's 45,000 rubles. It's a reward for those who manage to find most defects, most troubles, the biggest number of troubles. Right, thank you. $45,000 is, oh, I'm sorry, not dollars, rubles. At the current exchange rate, that would be, how much would that be? Roughly $500. Okay, Taras, your question. Yeah, I thought first to refrain from asking this question, but then I thought otherwise. Do you think that universal acceptance is fragmenting the internet? Don't you think that universal acceptance is the Tower of Babylon that will destroy everything, that will shatter everything into shards? Do you think, well, people who know what a domain name is and where to enter it in the browser aren't that many, and there are fewer of them definitely than those who speak English. There's universal acceptance So, okay, you will give people a domain name in the Russian language, but they will not know what to do with it. They will still find it using Google. They will still use it, they will find it, they will discover it using Google. They will not use this domain name as like where you would enter it, manually type it into the search bar. Well, I think that here we have people who are biased professionally. Internet has been our life for many years, and probably we see it and we understand it differently from the users, especially new users who are just joining the ranks. So probably, yeah, we should take a look at the internet and the universal acceptance idea with the eyes of the younger generation, maybe also with the eyes of the older generation who are driven to internet because of the lockdowns and other confinement measures. Why that RF is taking second place in the world as an IDN, and those not, I mean, in that statistics for a Russian, it is easy to remember an advertisement, an ad that has a domain name, in Slavic and Russian, like welcome to .rf. Добро пожаловать .rf. I don't agree that people are always using search. I mean, you have to. There is nothing that prevents you from remembering a name and entering it in the search bar, and you will get access to this resource that has this domain name, because in this search systems, the domain names inside the .rf zone are pretty well processed. They're well, they are handled efficiently. And secondly, the separation of users of the internet. You know, segregation into the Russian or the Indian or whatever internet. I understand it's discussed today, but universal acceptance has many different perspectives, and particularly UA is perceived as a way towards inclusive internet and a way to facilitate access to the internet to those people who do not know English. Even in our country, English, I mean, it's not very widespread. If I'm not mistaken, about 40% of people, no, I'm afraid to give you a wrong number, but anyway, I think about 40% of people who say that they know some English. But the rest of them, no. Of course, there are searches, and you can also automate your email, but it still causes difficulties to quite a big audience when they need to register an email box, and then they need to provide their emails to get access to different services. People have to switch to English, and they have to not make mistake in their name and a surname. You know that when transliterating, there may be problems. So it's something that's worth debating, but I see universal acceptance as a means to promote the multilingual internet, and as a means to provide access to the internet for the new audiences. And actually, there are different polls. There was a 2014 poll by Levada Sense, a Russian polling agency. 11% of Russians in 2014 said that they knew English. In 2018, a different polling agency says, 2019, that was 63% said that they knew some of English, but only 5% said that they are fluent in English. So, okay, someone doesn't know English at all. What should such a person do? What do you mean, what should such a person do? Well, you get online, and then what? Well, I'm looking at my kids. Kids go to YouTube, and they also use searches. But right now, it's a different trend. Platform development, media global platforms development, the media global platform that would incorporate everything, messengers, websites, like everything. And those platforms, well, basically, you want to promote a project like in for marketing purposes. Yes, there is still advertisement. Yes, you can use different services to promote your products or services, but you have to have a website. There must be a website. And some websites, I mean, one or another, you must have a website. And to have a website, you have to have a domain name. So when you enter those platforms, when you are searching for something, you will end up on a website. Those sites have addresses and people remember addresses. I'm sorry. We have two people waiting in line, and at the same time we're running out of time. Yeah, well, I agree. May I, Artyom, may I add something? The platforms, like Facebook. And Facebook, I think that Facebook is this very versatile platform. Facebook supports ID and domain names, but they do not represent them correctly. They do it in Unicode. If you make a post or if you send a comment, if you post a comment, the recognition is poor. The representation, the view is poor, and people sometimes when they see something like this, they assume that it's a fraud or it's some kind of a mistake or it's an invalid. So we really need those big platforms to support internationalization. Dmitry Serbolov was waiting online for a long time. Dmitry? Well, I understand where this is coming from, but I wonder in Facebook or in your email, what if you start receiving email in Chinese hieroglyphs or Arabic script? How are you going to use that? Dmitry, this is a standard question that we receive from the technical audience, and I believe that of course, you are using Russian to communicate with people who you know understand Russian. So when we talk about internationalized mail, most likely it will be used in communication with people who are inside your country or, well, who share the language with you. They belong to the same Russian-speaking or whatever-speaking community. We are not imposing Cyrillic or Arabic onto the whole world. We are trying to facilitate communication for people belonging to the same language. And Taras said that potentially this can lead to defragmentation, but I think you should treat this as a convenient tool for those people who work inside the country. Not all of us have international partners. Not all of us have friends abroad or relatives abroad. Yeah, I understand this. Just please understand that you are now preaching to people who don't understand what they are getting. You are preaching a Tower of Babylon, and when they start sending letters to help desks of international companies using their Chinese character email addresses, I think it's something that should not be done, period. Well, time will tell. Let future generations be the judge of how efficient this approach is, but and I just know that there are people who find it easier, who find it more convenient, more comfortable to work in their native language. And we have one last question for the day. We're already behind the schedule, but that Mikhail was waiting for a long time. Yes, hello, Masha. This is Mikhail Klimarev speaking. Do you have statistics on the use of those domain names in different languages? Is there a resource where you could go and see how many ID and how many domain names and how many email addresses you have in .rf or .ru? Do you have statistics on the real usage? How big is non-Latin character email address space? In fact, like the actual traffic data. Okay. For the Russian domain name .rf, you can go to statdom.ru. This is a resource that collects statistics on the national domain names, on the CCTLDs in Russia. The information about the registered domain names is regularly updated there, and also you can find information on the use. About 90%, more than 90% of domain names are delegated, they're in use. And roughly, I made a presentation in July, and I remember about 70% of them, they are used both for websites, for the email, and parked. I think it was like 11% or 15% of them are parked. They're in parking. So basically 60–70% of the domain names in Russian, they're used for unique resources, websites, pages, and email. China is in the first place. They have 1.8 million domain names registered. I do not have any information on how they are used, but I know the number. Even just looking at this number, which is impressive, it tells you that there is demand for those services, and there are websites, and you can find them in the internet, where people work with emails in the native language. The thing is, very often promotion of IDN domains is related to email support. I mean, if you have a domain name, if you can support an internationalized domain names right now, yeah, you can register such domain names, but you can only use it today for your website. Of course, you can set up an email account in the native characters, but it will not be received elsewhere. Like you will not have many receivers for it. Yes, I understand, and I understand also about the time. I opened the report at StatDom. I'm looking at it right now. February 12th, 813,000. Right now, 730,000. So to say that there is a great demand, well, I wouldn't claim that. Okay, Mikhail, let's not discuss that. I will explain. You understand it. I hope you understand that it's not proper to compare data from several years ago and now. It's 8 years. That was 2012. In 2012, 800,000. It's a downward trend. Okay, I understand the question. Okay, I'll explain why there is no jump in this number. Our analysis shows that domain names in the .rf zone, and it's a challenge, they are used by individual entrepreneurs, the self-employed people, or small businesses, SMBs, for their projects. We know that SMBs do not have a long life. And they often re-register, and they often change the line of business. So there is a constant replacement of old addresses with new ones. They are not renewed. People, instead of renewing, they register a new name and they drop the old one. So again, domain names, they also need email address. It's not the same as .ru. From the technical point of view, it's not the same as .ru, although there are RFCs, and technically this is all executable. And yes, not all of the software is UA ready, but we are making headway, and hopefully in a year or 2 years' time, and I will refrain from making projections, the process is on the way. And if we deal with the issue of the email email address as support, I would be curious to see how the statistics would change. Thank you. Thank you. If you have any further questions, please write to me. I'm open to the dialogue. I'm ready to argue different points of view, and especially if you see some drawbacks or defects in this concept, please get in touch. Yes, and Maria's contact details and the presentation is on the website, and that was the last presentation for Thursday. Thank you very much for staying with us until that late in the day. I'll remind you that ENOG resumes its work tomorrow, and tomorrow is the last day of the conference. And tomorrow, there will be presentations on NET64, and there will be just a sec. Yeah, there will be one more presentation, not just on NET64. Well, there will be also a presentation on new transport protocols and a roundtable discussion, telecoms in the time of the coronavirus pandemic. Tomorrow's session begins at 2 p.m. Amsterdam, 3 p.m. Kiev, and 4 p.m. Moscow time. Here, same place, tomorrow. Do not forget to rate the presentations. Thank you very much, and see you tomorrow.